Hi everyone, welcome to lesson number 2, the third lesson in the Introduction to Root tutorial. So last lesson went a little long, which is doubly frustrating because I found out that the audio was pretty miserable and it's really too long for me to want to go and redo it. I can't help but experiment and play with different settings, and I learned something that definitely doesn't work. Hopefully we're making improvements this time around. Okay, so I'm going to split this next one up into 2 more bite-sized chunks. So what we're going to do is talk about how we look at data points into root. How do we deal with them? How do we draw them? How do we make them? And then in the next lesson, we're actually going to fit data with the T formulas from last time, and now that we'll have data points to be able to use. So hopefully these 2 will be a little bit shorter than last time. Okay, so first off, we need some data that we can fit. So let's get something going. I'm going to open up an Excel spreadsheet, and let's make some pretty simple data. So let's count down 1, 2, 3, and let's equal that plus 1, not plus exclamation point, plus 1, and we'll fill that down a little bit. All right, now I've got some x-axis. Let's do some y stuff. So 3 times x minus 5. Why not? There's some data. Pretty boring stuff, but we'll get to things more interesting later on. So to be able to put this into root, this really could be any data from any spreadsheet. We're going to save this as a tab-delimited text file. So let's just click save, and I'll call this data.txt. Okay, yes, I want to keep using that format. Now, that's one way to do it. I think using Excel is a pretty natural and easy way. You can always just take data and type it in directly with Emacs or whatever text editor that you've got. And we are going to plot this in just a few very short, very easy lines of root. Now, some programs like MATLAB can read Excel files directly. Root can't. Root can read text files that are delimited pretty clearly, but then again, MATLAB costs like $10,000 and root is basically free. So let's take a look at what this data file I made looks like. So we're going to open up as soon as things keep rolling. Okay. Data.txt. So that's it, just 2 columns of data with a tab between them. Not a big deal. Okay, so what we're going to do in root is read these in using a graph object. Now because in root everything starts with the letter T, this is going to be a TGraph. So let's play with this on the command prompt first, and then we'll make a macro that does it. Okay. So I like to start them with G equals new TGraph, and we will tab and see what our options are. Now, normally, the way that you're intended to use it is 2 options. The easiest way is like we have now. We have a data file. I can just give it the file name, and I could even specify the format, and it will load up. The other thing that's common is if you have an array of x values and an array of y values, you can use one of these that says I've got in data points, here's the x values, here's the y values, and go. I'll actually show you a quick workaround, kind of a very quick and dirty hack that we can use in a little bit. But for now, let's just open up our data.txt. If it can't read the file, you might have seen an error message here. So now we need to draw this. So G draw. Let's see what we've got. My data points are hiding under there. They're invisible. They've been connected with a line. So let's see how we can control this. When I draw, The draw for graphs is unfortunately pretty different from everything else, and that change in structure is a little annoying. Generally speaking, if I want it to give me a new set of axes, I'll give it an A, and that will calculate what the x and y axes need to be to fit my graph. Then I'll want to do a few options. If I want it to draw my data points, I can do a P. And if I want it to draw a straight line, I can give it an L. And if I want it to draw a curved line, I can give it a C. That perfectly connects my data. So if I just do a P, I get data points. Now these are infinitesimally small single pixel points that are probably too hard for you to see. So let's just go into the editor. Now that will open up the edit toolbar on the left-hand side. Then I'm going to click on my data, and I'm going to change the marker here from a tiny little pixel to something else. And I can make them be a different color if I want. Okay, so now I was able to read in and plot some data points from a text file with literally 2 lines of code. I think that's pretty cool. Let's go ahead now and show you a few other options, and we'll save this to a macro and call it a day. If you don't want the data points but just a line, you could give it an AC, and that would draw a smooth line, a cubic spline interpolation through the points, or an AL would do just the 2. I could do P and L together, and I could get the points and the line at the same time. So a really easy way. Let's now save this in a macro so we can save our work and be able to use it again later on. So over to Emacs, we're going to make a file, and I'll call this graph1. Okay, so example of reading a data file and plotting. So I'll open this up. And we will say G equals new TGraph, and I'll type data.text. And now we can set some features about this that we want. So let's come back here. If I go to View and I click on Markers, this now gives me the codes for all of the different marker types that I want to use. So again, the default is 1, this tiny single pixel. It's much more common to use things in the 20s, squares, circles, diamonds, stars. Things that look prettier. So let's set that. So I will do G, set marker type. And then I just have to give it a number here. So let's do squares. So I'll do 21. And I could say set line color K red. Any other things that I want to, we could do set title, data plot with TGraph. And I've got my x-axis in gigawatts per millisecond. There we go. Okay, G draw, axis, line, and the data points. Let's see if that's going to work for us. So .x, graph1.c. Okay, set marker style was the wrong one. So, sorry, set marker type was the wrong command. Let's figure out what I did wrong. G set marker style. Marker style and marker size are what we're going to need here. Okay, so let's fix that. Set marker style. Now you can memorize everything. Clearly I don't. As long as you're close enough that you can guess, tab completion will bring you the rest of the way home. Okay, I'll save this and let's try running it again. Alright, what does our plot look like? There we go. So this is the marker size. It starts off as 1, and you could change that to be as big or as little as you want. Okay, so now we've got a good way of plotting data in Root. Let me show you a second way to do it. So this time, let's use the SetPoint command, and then we'll throw in some fake data with a random number generator instead of a really goofy Excel formula. Okay, so we're going to make a new macro that fills this up in a different way. So let's go to graph2.c. Example of graph with SetPoint. Okay, G equals new TGraph, and this time I'm just going to leave the constructor blank because this is going to be the quick and dirty, lazy, simple way of making a graph. So let me show you how this works over here on the prompt, and then we'll go in and fill in the macro. So G equals new TGraph. So now G is pretty boring. It doesn't have anything interesting inside of it. If I did G draw, ALP, illegal number of point 0. So what I could do is manually add points one by one with the SetPoint command. Now we're going to start counting on point number 0, but I could give it an X value and a Y value. And then I could say, all right, point number 1 gets a new X value and a new Y value. And then if I draw this, now my graph, let's close this marker types window, now my graph has my 2 data points. So let's make the markers large and red. So I can use the SetPoint command inside my code to add points one by one as we go. So if I do a calculation and I figure out what the Y value is, instead of storing all the X and Y values in arrays to graph later on, I can just use the SetPoint once and forget about it. Root uses some clever data structures from the standard template library that will automatically grow every time I add a point. So I don't have to worry about the graph running out of space or knowing how many points I need ahead of time. Okay, so let's make this go. So I could start off with something simple like a for loop, and then we can maybe do something a little more interesting. So let's try this. For I equals 0, I is less than, let's do not too many, just 10 points, I++. So again, these root macros are C++. You can do whatever you want in here. So I'm going to say G SetPoint. So the point number first, so that's I. I can resize the window here so I see I get I, X value, Y value. I'll leave my X-axis, my X value as Y, so my X value as I. So now I need something. So let's do I squared minus 4 times I plus 7, just to make up a silly second degree equation. Okay, and we are done here. I guess I didn't really need those braces after all. So then we can do G draw ALP. So now this time let's go ahead and set the markers to be a little bit larger, to be visible, so that they will come up and plot correctly. I can just copy and paste those from the other macro or retype them, whichever is faster for you. So G set marker style 22, and let's give this a go. Okay, .x graph 2 variable I missing closed brace. Yep. Missing closed brace for the block opener on line 2, unexpected end of file. There we go. That's what happens when you code for real. Okay, so now I get a really nice plot. What you see is they've drawn a straight line to connect the dots. If I went back and changed this to an ACP, I would now get a smooth cubic spline that's connecting all the dots for me. So when this saves, we will run it again and take a look at the smooth line. Okay. So there we go. So maybe you can tell, maybe not. One thing that we don't really do a lot in science, but can be fun to do with root, is I can turn on some options like can edit histograms, and I can take a point and click and drag it around. Now, your thesis advisor will probably not be really happy if you choose to do that with your real data, but it can be kind of fun when you're messing around with root. So if I went back to my data points here, smooth line, simple line, and I have some other options that I'm not so interested in right now. Okay, let me show you some other ways that we could fill in some interesting looking data by using root's random number generator, and that will be the last thing in this lesson. The next time we'll combine graphs and the TF1s to fit some data. So for root, we have a lot of ways that we can generate random numbers that are really useful. So we've talked about how every class starts with a capital T, every constant starts with a lowercase k. The last one that we need is for global variables, and every global in root starts with a lowercase g. So when I fire up root, it starts one global object, that's the g random. Now this is our global random number generator. So now from here, I have a lot of ways that I can generate random numbers. So if you Google to pull up the reference guide, you can take a look at the complete list, but let me show you a few. So one basic is uniform, and that will give me a random number either from 0 to whatever the parameter is, or if I give two parameters between them. So I can get a random number from 0 to 10, or I can get a random number between 1 and 2. We can do, the most common is Gauss. That's G-A-U-S, not G-A-U-S-S. A mean and a standard deviation. Now in C++, when these have default values, that means I don't have to specify them if I'm okay with using the default. So if I say Gauss, I get a random number that's Gaussian distributed with a mean of 0 and a width of 1. So I can run this a few times, and I can get some numbers there. Let's use this and the SetPoint command to make some graphs. Okay, so let's come over here and let's make this a little more interesting. So now I'm just going to change this. So what we're going to do is fill in the x value and the y value with a random number, and let's do this with a few extra data points. 1,000 should be pretty good. Okay, so for my x value, I'll do grandom Gauss, and let's get a Gaussian that has a mean of 5 and a width of 1. Alright, great. Now for my y value, I'll do a grandom Gauss, and I'll have a mean of 0 and a width of 2. Then I make sure to close that and add my semicolon. Okay, so now when I run this, we'll have a nice Gaussian blob of data to take a look at. So let's .x our graph2.c. Really nice. Now if I'm going to do data like this that are just a scatter plot, connecting them with a smooth line really doesn't make any sense unless I'm doing art, and that does look kind of cool. And maybe I did a few too many data points, so we'll come back here. We will turn off the C and just do axis and P, and we'll maybe do 100 instead of 1,000. Okay, I'll try running this thing again. Okay. So I have a nice blob of data centered. The mean looks to be about 5 and x and about 0 and y. and we've got some graphs. So that's going to be it for this lesson. What we're going to do next time is take some randomly generated graphs, take some graphs of some other data, and we're going to fit them by having some new TF1 functions that have some arbitrary parameters. And let me say, fitting is one thing where root really, really shines. See you next time.